Okay, this is my first attempt at setting this puppy up. And what we're going to do is, rather than giving it a complete analysis, we're going to look and see what an acceptance test technician would be looking for when he comes in to test this. We'll see if it passes acceptance testing, because frankly, sitting here talking to you, I don't know yet. So let's find out. And then we're going to go into how this thing works, get it all straight in your head, how to set up this specific controller, and then hopefully you'll be able to set up any step switch daylighting system you should encounter based on the theories we're going to learn today, or at least in this series of videos. So let's take a look at what's going on here. The test technician comes in. He has a pad of paper, he has a pencil, and he has a pocket calculator. And he comes in and says, gee, I'm working in a daylit room. We have actual daylight coming in. How much is it? We have 20.8 actual daylight at our reference location. The next thing he is going to do, because he's a smart tech and he's familiar with this unit, otherwise he's going to have a problem. But the next thing he's going to do is look and see what the ratio of what the sensor sees, which is mounted behind this board, versus what he is finding at his task location he has chosen. Okay? So, according to the controller, the sensor is seeing 56-foot candles, actual daylight under these daylight conditions. The technician sees 20.8 actual daylight at his reference location. So he divides 56-foot candles, what the sensor sees, by 20.8 at the task location, and he ends up with a sensor ratio of about 2.69. That means roughly 2.69. For every 2.1 foot candles that appear at the sensor, as far as the controller is concerned, you get 1 foot candle here. Very important. The next thing he needs to know is what is his reference illumination. So because he's familiar with this critter, he's going to push the down button 1, 2, 3, 4, 5 times until it says run test mode, and then he's going to hit yes. Now, unfortunately, the photocell value is no longer displayed here. However, all the time delays have been defeated on this. So he wants to know how much electric lighting he will see in the place at 3 in the morning. So he goes to the open loop sensor and he covers it. Alright. Now he has all 3 stages of electric lighting on. So armed with the fact that he knew there was 20.8 daylight in the place, he's now got 51.4. So 51.4 combined minus 20.8 actual daylight is going to give him 51.4 minus 20.8 equals 30.6, or roughly 31 foot candles are being produced by all the lighting. Alright. He knows that's his reference illumination, and he is not to drop below that 30.6 combined at the task location. Now, he is going to take a continuously dimmable light source. He is going to put it where it will impinge upon the sensor. He's going to block out the actual light so that he can start from full output on the system and simply bring some lighting up. And let me make sure I'm not blocking the sensor. Hold on. I want to get in the way of that sensor. Okay. and we don't want to block the actual task area. Okay. He's looking now. He knows the system has to do several things. One, under no daylight conditions, it needs to be full on. Okay, we're under no daylight conditions. Under partial daylight conditions, as these snap off, the combined illumination at the task location should not drop below the 3 a.m. in the morning reference, which we got as 30.6. Okay, so we're simply going to take a continuously dimmable control, and we are going to run it up until we get a stage to switch off. Now there's going to be a significant amount of deadband here, so we are just going to move it up and 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 wait for it, wait for it. Now imagine doing this with the state-mandated 3-minute or more time delay still installed in the controller. You can see the difficulties that technicians will run into. Okay, that looks about right. At our task location, we're going to take our reading, which we will modify, and we're going to call this, and it's 42 foot candles, and that's going to be stage 1 cutoff. Okay, that's our actual reading. We're going to modify it because that's not what we're really interested in, but we need this. Next, he's going to take it out of test mode, let this thing power up, and it's going to give him the foot candle reading at the sensor from his dimmable directional light source. And in this case, we have 38 foot candles impinging upon the sensor as far as this controller is concerned. Now he has to find the next point. So we push 1, 2, 3, 4. First button push, when it's been sitting there, just turns its backlight on. He's going to put it in test mode. He's going to begin increasing his light on the sensor until he gets the next stage to just snap off. And I mean just snap off. You don't want to run past it, or you're just going to have to back off until it comes back on and repeat it. Okay, come on, come on, come on. Let's snap off. Come on, come on. There we go. Close enough for us today. We have 29 foot candles for stage 2 snap off. At the reference location, we take the controller out of test mode so we can get a reading off the sensor. He might also put his own light meter back there and secure it in place. Doesn't have to be this one. In fact, you need 2 different ones to do this. I've got 93 foot candles impinging upon the sensor according to the controller. Now let's find our last point. Put it in test mode. Increase the lighting. Increase until we just get this last stage to snap off. Okay, come on, come on, come on. There we go. Close enough. I have 20 foot candles at my task location. Actually, yeah, 20.2. What would I expect to see there? Well, when we started the test, we had 20.8 there, didn't we? All the lights are back off, aren't they? So what we're reading is nothing but daylight coming in. And I've got 20.2. I started out at 20.8. This is one of the reasons you want to move on this test. From this point on, any additional illumination that shows up in the area is going to be increased. If it's increasing, it's all going to be daylight. Let's exit test mode. Let's take our last foot candle reading off of the sensor. I've got 119 foot candles. Okay. Well, that was fun and interesting. Now let's do some math. At our actual task location, we are reading 42, 29, and 20.2 or so. What we want to do is determine how much of that's electric. So we subtract the actual daylight out of all of these, and we'll just call it 20. So 20.2, okay, 20.2. So I've got 22 foot candles. 42 is what I read, minus the 20 or so is 22. 29 minus what I read, we'll call it 9 foot candles. And 20.2 minus 20.2 is 0 foot candles. Okay? That would be the electric light that we're seeing here when a stage just snaps off. But we're interested in combined. But look, the sensor can't see into this area. So what we have to do is take these sensor readings, and believe it or not, this is what an acceptance test technician has to do. And as a commissioning agent, you should go further than this. And we'll go into this so that you can fine-tune this puppy and make sure it's working completely. Well, what we're going to do is we're going to take all the readings that we took off the back, and when we started out, we had 56 on the back and 20.8 on at the task of actual daylight. That gave us a sensor ratio of 2.69. We're going to take all of our sensor readings off the back and divide them by 2.69. So I've got 38 divided by 2.69 equals, about 14 foot candles. I've got, when the second stage snapped off, it did it when the controller told me there was 93 back there. So we're going to divide that by 2.69, and that gives us 34.5 foot candles. And then when the last stage snapped off, the controller said we had 119 foot candles on the sensor. We're going to divide that by our sensor ratio of 2.69, and that gives me 44.23, which tells me that the last stage has not been calibrated properly on this. So somehow I goofed that up. However, it does meet acceptance testing. Let me explain. What the technician's looking for is a combined illumination here as each stage snaps off that does not go below 30.6, which is what we measured for our combined electric, but does not go over 150%, which would be 45 and a skosh. So we'll go 30.6 times 1.5 equals, our not to exceed value is, wait a minute, 30.6 times 1.5 equals 45.9, we'll call it 46. So all of our combined readings should be between 30 and 30.6 and 46 foot candles. In order to get the combined illumination, we had to take our actual electric lighting of each stage that we saw at each cutoff point and add in our calculated daylight, so we get, which we got the actual sensor and divided by the sensor ratio. We've got 22 and 14 is 36 foot candles. That's in the zone. We've got 34.5 and 9, which gives us 43.5. That's in the zone. And the last one is 0 because all the lights were out. And our calculated daylight reading of 44.23. So that's in the zone. It's also a really lousy alignment. Okay, so we'll figure out how to calibrate this better than my first shot at it. Wow. Okay, so it meets acceptance testing. It's a little on the high side, actually. It's a lot on the high side. But that is basically all the acceptance tester has to do. And so he has a reference illumination of 30.6. He has partials of 36, 43, and 44. They must lie between 30.6 and 150% of that, which is 30.6 and 46 or so. So he's in the zone. And then when the last stage of lighting goes out, he has to be above his reference illumination, which is 30.6, so he's there with a 44.23. So this is an overly bright system, but it is not a bad system because it actually passed acceptance testing.